Pen, today we'll be tackling the advanced question in our statistics quiz number 2. The question states, individuals with low bone density have a high risk of broken bones, fractures. Physicians who are concerned about low bone density osteoporosis in patients can refer them for specialized testing. Currently, the most common method for testing bone density is dual energy X-ray absorptiometry, or DEXA. A patient who undergoes DEXA test usually gets bone density results in grams per square centimeter and in standardized units. Judy, who is 25 years old, has a bone density measured using DEXA. Her results indicate bone density in the hip of 948 grams per centimeter squared and a standardized score of Z equals -1.45. In the reference population of 25-year-old women like Judy, the mean bone density in the hip is 956 grams per centimeter squared. Just like with any word problem, the most important thing is to pick out what's most important. So the first paragraph doesn't really give us any information, but gives us more of a context of where the question's coming from. What's important is all located in the second paragraph. So what I did is I went ahead and pulled it out so you could see it on the sheet right here. I labeled Judy's bone density of the hip to be 948 grams per centimeter squared. Her Z-score is -1.45, and then the mean bone density to be 956 grams per centimeter squared. Knowing all of this information, we should be more than ready to move on to Part A. So what Part A is asking us is explain to Judy in simple language what the standardized score tells her about her bone density. So the first thing that we might want to do is figure out what the standardized score is indicating to us. So a standardized score, or your Z-score, is basically the number of standard deviations away from the mean you are. So we remember that her Z-score is -1.45. So this means that her score is approximately 1.5 standard deviations away from the mean. The next important part about her standardized score is this negative symbol right here. This means that her bone density is below the mean. If your standardized score has a negative preceding it, that means that you are that many standard deviations below the mean, and if it was positive, it would be 1.5 standard deviations above the mean. So for the context of this question, Judy might be concerned because her bone density is relatively lower than the mean, and so she might be susceptible to getting osteoporosis. So we have just tackled Part A, and it's on to Part B. B asks, use the information provided to calculate the standard deviation of bone density in the reference population. So in order to do this, we're going to have to use that equation that we used in question 1. In case you don't remember, it's the given value minus the mean over standard deviation equals your standardized score. So if we plug in what we know to this equation, we're going to have to use Judy's information again. So our given value is Judy's bone density, 948, minus the mean bone density, 956, all over standard deviation, and we're not sure what that is yet. And then we know that Judy's bone density gives us a standardized score of -1.45. And from here, we'll just have to work backwards. The first thing that we're going to want to do is rewrite this a little bit so it's easier to see. 948 minus 956, this is equal to -8. Alright, so from there we can move this over there by basically timesing the standard deviation on both sides. Alright, so what the equation will look like now is -8 equals -1.45 times the standard deviation. And then from there, we'll divide both sides by -1.45. And that will leave us with approximately 5.52 equals the standard deviation. And that should be your final answer. So the standard deviation of the reference population is approximately 5.52. And just a quick recap of how we did this. We plugged Judy's information into our equation and then took her standardized score and kind of worked backwards to figure out what we didn't know, which in this case was the standard deviation for the population. And that sums up question number 2.